Hello and welcome. Today we'll look at Swerve input system that we usually see in hyper-casual runners. Let's dive in. So this is a project I have set up earlier where there's a player with animations enabled and he just runs straight forward. Our aim is to implement the swerving mechanics so that we can dodge these red boxes and go to our destination. Let's see how it works at the moment. Here it's asking for tap input to play. We'll tap the screen and we see the player moving, but it gets stuck on the box. We can't swerve right now, and we'll implement the swerving mechanics here. Let's create a script called Swerve input system. We'll remove the default functions. Now let's take a moment and imagine how the swerving mechanics in a hyper-casual game works. Let's take a moment to think about how the swerving input works, right? At first you put your finger on the screen and you start swerving it from left to right, and the player will follow the movement you make on the screen and move accordingly. And there's no specific point where you need to touch. You can just touch anywhere on the screen and start swerving. At first, we'll have a variable that will save the input position of the last frame. At first, we'll create the update function and lay the skeleton, which means we'll create the condition where user puts their finger on the screen, the condition where user keeps their finger on the screen, and the condition where user takes their finger off the screen. Now what we'll do is we'll compare the position where the user's finger is at the current frame with the position where the user's finger was on the last frame and find out the movement it made. To do this, first we'll have a variable that will keep track of the last frame's finger's position of the user. We are not saving the vector2 of the last finger position, rather we are saving the x position only, because during swerving we only care about the x value. Now we'll create another variable that will keep track of the move factor, that means how much we are moving compared to the last frame. Let's update the last frame finger position x. Whenever the user takes their finger off the screen, we'll consider the move factor x to 0, because when the user is not touching on the screen, we'll not consider it a movement. Let's create a property for the move factor x, and we'll access that from another script using which we'll move the character. This script processes the input of the user, and now we'll create another script that will actually move the player. We'll start by taking a reference of the Swerve input system. Now we'll take advantage of the move factor x variable of the Swerve input system and move the player in the update function. We'll multiply this value with time.delta time, and we'll have a serialized field for the swerve speed. Now let's attach these two scripts to our player game object and see how it works. It works fine, but there are some issues here. If we move our fingers really fast, the players shoot off in the swerving direction. So this is a problem that can be addressed by having a limit on the swerve speed. Not exactly the speed, but the swerve movement, right? Let's do it now. At first, we'll have a maximum allowed swerve amount, right? So we'll have a float value which will define the maximum amount of swerve that we will allow here. Let's create that value first. Okay. This swerve amount value can be a negative or a positive value depending on if we are swerving left or right. So we'll clamp this value between the negative max swerve amount and the positive max swerve amount. Let's see if this solves it. You see, when I'm swerving really fast, the player is not shooting off. It has a limit there. So this is how you can implement a swerve input system and a swerve movement system in a hyper-casual game. If you have any questions regarding this, you can ask them in the comment section and I'll try my best to answer. Thank you.